Hi everyone, in this video we are going to practice working with hydrocarbons. So these are something that you just have to memorize, but the more you use them and go through practice problems with it, you start to just kind of pick them up and pick up the formulas, pick up some properties, and so I would just highly recommend doing a couple practice problems that involve hydrocarbons because then it's just a little bit easier and you don't have to actually sit down and memorize it, which is kind of boring. So let's go through a couple of these. Let's just start off with something very simple. Please write out the molecular formula of propane, butane, and heptane. Okay, so this is something you should have memorized. Go. All right, did you get an answer? Hopefully you did, and the first thing you had to do is start off with the very basic structure of a carbon and a hydrogen, right? This is hydrocarbons. That means they're only comprised of hydrogen and carbon. They end in A and E, which are the alkanes, meaning that they're single bonds only. I'm never going to give you an ene without giving you some extra information. So for propane, literally all you have to do is look at the pro and go, okay, what does propane mean? What does the pro part mean for a hydrocarbon? And know that it means 3. So that's telling you that you have 3 carbons. Once you have determined this number, you can use that to determine how many hydrogens you have. So remember, what you have to do is just multiply that number by 2 and then add 2 to it. So 2 times 3 gives me 6, plus 2 gives me 8. So it's C3H8. So we'll do the same thing with butane. But tells us that there are 4 carbons, so this is C4. Now we have to figure out our hydrogens. So remember, it's 4 times 2 plus 2. So 4 times 2 gives us 8, plus 2 gives us 10. Okay, so you can see 8, 10. You can start to pick up on these patterns, all right? Heptane. Hept, such a beautiful word. Hept is telling us that there's 7 carbons. So 7 times 2 gives us 14, plus 2 gives us 16. So we have C7H16. So you really don't have to memorize this. You can figure it out, but just know the patterns, know how you have to kind of walk through it all, okay? All right, so the next question here is, what phase is nonane at room temperature? All right, I'm telling you it has a boiling point of 151. I'm telling you it has a melting point of -51. So at room temperature, what phase is it? So the first thing you have to do for this problem is remember what room temperature is. And room temperature is 25 degrees Celsius. Okay, so the melting point of nonane is below room temperature, and the boiling point of nonane is above room temperature. So what that means, hopefully right away, is that you know that you have a liquid. Okay, you have a liquid. So this is something that at this temperature, at -51, it's going to go from a liquid to a solid. So we're definitely at liquid phase at 25. And then we know at 151 degrees Celsius, it goes from a liquid to a gas. And so we know we're definitely at a liquid here at room temperature, okay? Be able to do this. If I give you boiling point, melting point, you should be able to tell me what phase it is at room temperature, okay? All right, next one. How many single bonds are in pentane? So the first thing we have to do with this problem is we need to figure out what pentane is. And so pentane, pent is telling us that there's 5 carbons. So the hydrogen component is going to be 5 times 2, which gives us 10, plus 2 gives us 12. So C5H12 is what pentane is. So now you just have to draw it out. So 1, 2, 3, 4, 5 carbons, and now there are 12 hydrogens all the way around it. Okay, so maybe some of you are able to do this in your head, which is awesome. I guess I probably could, but I would draw this out just personally because I think that's easier. I don't like making mistakes, and so for me, that would be the best way to check it. So you do your formula first, then you draw it out. Now we count our single bonds. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Is that right? Yes, okay. Whew. 16 single bonds in pentane, all right? So you do your formula, draw your structure, count your bonds. Pretty simple. So now we're going to make it a little bit harder. What is the molecular formula of hexene? All right, so here's that ENE. I am giving you, though, the structure. I need you to tell me what the molecular formula is. Go. All right, did you get an answer? Hopefully you did. If you didn't, don't worry about it. But the first thing you should have done is gone, oh my gosh, I recognize this. Hex, I know that means that we have 6 carbons. So right away you should have gone carbon 6, and then you know you have a number of hydrogens. You know that hexane, okay, the one you had to memorize, hexane is C6H, so times 2 plus 2, so that's 14. All right, so that's what you're going on. If you are able to count all these up and end up with this formula of hexane, you know you did something wrong. Okay, so just keep this stuff in the back of your mind. Start cataloging it all. All right, so let's go through here and just confirm, though. So we have 6 carbons. 1, 2, 3, 4, 5, 6. That's correct. Now we need to count our hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I get 12 hydrogens, which makes sense because we have a double bond here instead of a single bond, which means we have 2 less hydrogens when we go from hexane to hexene. All right, so imagine I've given you this information on an exam. All right, we did this problem. We went from hexane to hexene. You see the pattern. You know the pattern. Answer this next question. What is the molecular formula of pentene? Okay, I'm not giving you the structure. You do not need to Google anything. You should be able to do this based on what we just said. Go. All right, did you get it? Oh, I hope you did. I really hope you got it. All right, the first thing you're going to do is start with pentane. Okay, pentane's the one you know. You know that carbon has 5. There's 5 carbons here for pentane, and then we have hydrogen, so it's going to be 5 times 2 plus 2, so that's 10 plus 2 gives us 12. So that's what pentane is. We saw in the last question that when you go from pentane to pentene, we drop 2 hydrogens. So right away you should have said, okay, I know that there's 5 carbons, there were 12 hydrogens, but in pentene there can only be 10. So what is the molecular formula for pentene? It's C5H10. Let me check, make sure that's correct. Yes, absolutely. All right, good. So hopefully that makes sense. Hopefully you're able to start seeing these patterns. I really hope this is getting easier and easier for you. If not, you need to spend some time with some flashcards. There's only 8 hydrocarbons I've asked you to memorize, so get those down now before you even get to the harder stuff. Good luck. Have a great week. Take care of yourself. Drink water.